Boys, I'm going to show you an example of displacement. And displacement really means pushing something out of the way. And it's always the strongest, most reactive thing that pushes things out of the way. And I'm going to demonstrate. I have got 3 chemicals here. That is copper sulfate, zinc sulfate, and magnesium sulfate. And I've got 3 types of metal. I've got magnesium, zinc, and copper. And I'm going to add them all together, and we're going to see what happens. Firstly, let's do the copper sulfate being added to the 3 different types of metal. Copper sulfate on magnesium, copper sulfate on zinc, and copper sulfate on copper. And it looks like something's happening. Right, let's try zinc. Zinc on the magnesium, zinc sulfate on the zinc, and zinc sulfate on copper. And the last one, that was magnesium sulfate on magnesium, magnesium sulfate on zinc, and magnesium sulfate on copper. Well, looking at these, all the action's going on here. They've gone black. These bits of metal have gone black. It looks like some sort of reaction. Now that tells us that the magnesium is more reactive than the copper. The copper is in the magnesium, the copper is in the copper sulfate. The copper is attached to a sulfate. But this magnesium has come along and just pushed the copper out of the way. It's just displaced it. Similarly here, the zinc is more reactive than the copper. Remember, the copper is in the liquid, the copper sulfate, and the zinc has pushed it out of the way. Over here, though, we can see, well, there's a little bit going on here. Just here, we can see that actually the magnesium is more reactive than the zinc. The zinc was in the liquid, the zinc sulfate, and that has pushed it, and there's a reaction and it's bubbling away. But in the last column, the last row, when we added magnesium sulfate to these 3, absolutely nothing happened. The magnesium is very strongly attached to the magnesium sulfate. Magnesium does nothing. The zinc can't push the magnesium off the magnesium sulfate, and copper can't push the magnesium off the magnesium sulfate. So that tells us the most reactive one, the most reactive metal is the magnesium, and then the zinc, and then the copper. Copper's rubbish, but it does look nice. That is a nice bluey colour, isn't it? You cannot argue with that colour. Boys, I'm going to show you a displacement reaction. A displacement reaction is where there are 2 substances and one is more reactive and it will push something else out the way and grab whatever it was grabbing onto. So in here I have got aluminium and iron oxide. We should see that aluminium is more reactive and it'll push the oxide off the iron. It'll displace the iron and it'll be a big reaction and it should leave behind the iron. This bit here is magnesium. The magnesium doesn't really play any part in it, that is just because it needs a lot of heat to get going. And you are aware that magnesium doesn't half go. Let's heat it up. Right, that's the fuse. The fuse is lit. Right, now I'm looking at that, I can't see a lot, I've just got a great big green spot in front of my eyes and I can't see. When that's cooled down, we're going to look in there and hopefully we're going to find a piece of iron, which has been pushed away from the iron oxide. Alright, let's see if we have some iron. I'm going in with a magnet. Oh, don't want to stick to this, I'll hold that still. Right, those bits there that are stuck to my magnet, those are bits of iron. We have just made pure iron by displacement. We have displaced the iron from the iron oxide by using aluminium. All right, there we go. Hi, I would like to show you today how to predict what's going to happen and write some word equations for displacement reactions. And displacement is just a posh word, and it means pushing something out of the way. Pushing one thing, pushing something else out of the way and grabbing hold of something, which is all we're doing. Now, you should have hopefully seen the video that goes with this, and this is just going through the results of the video, and then we'll just try and work out what's going on with each one. Now, the first one, we tried magnesium with copper sulfate, and what we found was there was a reaction. They reacted together, something happened. Well, that's because the magnesium is more reactive than the copper. The magnesium is so strong, so reactive, it can go up to the copper, grab the sulfate, steal the sulfate, and go off again, leaving the copper with nothing. So I'm going to put the magnesium there as being very reactive. It's reactive enough to steal things from copper or to displace things off copper. If we try magnesium and zinc, well, what happens is we discover that zinc, there's also a reaction. Magnesium is able to displace the sulfate from the zinc. Now, there's no point trying magnesium with magnesium, so I'm just putting an X there. Now let's try zinc. Well, we saw the video. In the video we saw that zinc, copper sulfate, what happens is there is a reaction. Now that tells me that zinc is more reactive than copper. Zinc is more reactive than copper, so I'm going to put that to the purple. Magnesium is more reactive than... sorry, zinc is more reactive than copper. But now I try zinc against magnesium sulfate, and what I find is that, well, nothing happens. Nothing happens at all there. Now that tells me that zinc is not as reactive as magnesium. Now, we already knew that magnesium was reactive, so I'm going to make that one red again, just make sure we definitely know that's definitely red. Magnesium, very reactive. Zinc, it's quite reactive. It can steal sulfate away from copper, but it cannot steal or displace the sulfate away from the magnesium. Copper then, let's try that. Well, we've seen the video, and what we discovered was here is nothing happens. The copper is unable to steal the zinc sulfate, so the zinc is definitely more reactive than the copper. So I'll colour that in, make it a purple. Zinc is more reactive than copper. And copper, well, we've seen it. Nothing happens. Copper cannot steal things away from magnesium because magnesium is much more reactive. The copper cannot displace the sulfate from the magnesium. Now that tells us which of those are the most reactive. We've got three types of metal. We know that magnesium is the most reactive, zinc is the second, and copper is the least reactive of those metals. Now there's a big long list, a long series of metals or substances which tells you how reactive they are compared to each other, and it's called the reactivity series. Now somebody came up with a nice phrase to help you remember. It is, please stop calling me a zombie, I love hot chicken soup. And the first letters of each of those tell you the name of one of the metals, and the most reactive ones are at the beginning and the least reactive ones are at the end. So, based on this list here, we see please for potassium, S for sodium, C, another reactive metal beginning with C, that would be calcium, M would be magnesium, A is aluminium, Z would be zinc. Now I don't know why that is spelt correctly, I do not know why that's underlined, but such is life. So we've got zinc, potassium, sodium, calcium, magnesium, aluminium, zinc. And then I would be iron, L would be lead. H would be hydrogen actually. That would be hydrogen. Now that's coloured red because that's not actually a metal, but it does turn out for various things that's a really important one to remember. C was another C. We've had calcium. It's not calcium again, it's actually the C that's not very reactive is called copper, and S is silver. Now there's a couple of metals missing from that list. There's lithium, there's mercury, there's gold. Well, the list could be very, very long, and wherever you look it up on the internet, you'll see a different list
The order's always the same, but some of them miss some things out and other lists miss other things out. Don't worry about knowing every single one. But roughly, there's a pretty good list. Let's try and work some of these out then. Let's try and do a few just straight from the equations. So, iron and silver sulfate will be the first one. Now, if we look at those, please stop calling me a zombie, I love hot chicken soup. We can see from that iron, I've already coloured it, it's in red. Iron is quite reactive and silver not so much. So the iron is able to go up to this sulfate and steal it away from the silver. Sort of like doing that really. Just like that. So if we colour that in, iron sulfate and silver. Now if we look at the second one, I've coloured them in again. Well, it's the same substances actually. Supposing we would start with silver but iron sulfate. Now silver is not strong enough to go up to the sulfate and displace it away. Can't do that. Iron is too reactive. So we get no reaction, nothing happens. Third one. So let's have a think. We've got zinc and copper. Which of those two is the most reactive? Well, looking along this list, there's two C's, isn't there? Two C's. The first one is calcium, the last one is copper. Potassium chloride, sorry, zinc is zombie. Right, so that one there is going to go to red, that one there is going to go to purple. Right, well, if zinc is the most reactive, can it grab the zinc, can it grab the sulfate away? Yes it can. So, we're going like that. Okay, potassium, chloride and iron. Well, I don't know. Do you want to just take a moment and just see, can you work those ones out? If you just have a look down that list and see if you can just work them out. If you want to just pause this video and see if you can work them through. Think about which is the most reactive, which is the least reactive, which is the thing that's getting moved around. Just have a quick pause. Right, let's have a go then. So in this one here, just to confuse you, we've got chloride instead of sulfate. So chloride, that's the thing that's just getting passed around the place. That's the thing that's just getting moved around. Looking at these, which of these two is the most reactive? Well, if potassium's there, it's always going to be potassium. Iron is, in this case, it's the less reactive one. So I reckon nothing's going to happen there. There's nothing going on. Alright, different one in this case. Potassium is much more reactive. It can steal the chloride. So yes, we've had a change. The chloride went over there. Silver nitrate and magnesium. Well, the most reactive one is magnesium. So that is able to drag that nitrate over. So we're going to get magnesium nitrate and silver. Third one, well again, potassium's there. It's always going to be potassium's the most reactive. So that is able to steal the nitrate across. So we have got potassium, nitrate and magnesium. I don't know why it's putting these as spelling mistakes. Not anymore. Funny old world. I'll have a word with Bill Gates later. Iron and copper chloride. Okay, that is telling us that iron is more reactive. It's able to steal the chloride away from the copper, and this last one, no reaction. Copper and potassium chloride, no reaction. Okay, and that is because potassium's already got the other thing. It's already got the other ion, and they're unable to move around. Hopefully you got those. Here's some more, and it's just the same thing, but it's just written out. Written out for you. I'm going to just remember that phrase, please stop calling me a zombie, I love hot chicken soup. I'm going to move that off the screen. If you can just go through that and try and work them out. Take a moment, and in a moment I will reveal them. I think this one should say, that's got a word missing there, isn't it? That should say nitrate or sulfate or something. I don't know what it should say. Let's say sulfate. Whatever it is, that's my mistake entirely. Okay, I'm going to go through them, but I think really you should have had a go at those, writing out the whole thing each time. So the first one. Now there might be a mistake here because if it's, I just added the word sulfate there, didn't I? So let's have a go. Oh, I was lucky there. Iron and silver sulfate. Yep, doesn't matter which way around you put those. But whatever happens, the sulfate is going to move across the iron. It has. And again, it doesn't matter which way around you put those. The next one. No reaction. Copper and zinc sulfate. Well, the most reactive one there is zinc, so there's going to be the movement. The sulfate is going to move. This one. Iron and potassium chloride. Well, potassium's the most reactive. It's already got it. It's already got the chloride, so it will not move. And this one here, potassium and aluminium chloride. Potassium's the most reactive. The chloride will get displaced. And the last one, oh, you've been given some of it there. I don't know why, but such is life. Okay, so I hope that was reasonably easy. You got the idea. If you're not sure, just go back and watch through it, watch the video of the actual experiment if you want to, and watch the actual word equations. Try and remember that reactivity series as well if you can. Alright, thank you.